Swayam Prabha. Digital India. Educated India.
So, my hearty good morning to one and all present here. Myself, Dr. Srinivasan from IIT Trichy and my research scholar Tulasi. We are presenting together, okay, something different from others. Real-time detection of false data injection attack and industrial conveyor belt system. Thanks to a last presenter, he already introduced about what is cyber physical system. So these are all the introduction and overview and challenges and what is that, what we are planning to do that. So the cyber physical system, it's order of the day because so basically now everything is like, wireless environment. So we are connecting all the information to a cyber. Okay, that's okay, we are able to. Okay, so the cyber physical system integrates sensing, computational. The cyber system integrate a sensing, computational, control and networking into a physical object in infrastructure, connecting them to internet to everywhere. So basically now we have a large industrial process. Now what happened? All the sensor information and transmitter which is going to a cloud. So now the computation, everything is happened. Somewhere it is sitting in a somewhere in a world. Okay, then again it's back. Okay, even though this particular part, still the people are not relying on that industries and other perspective. Still, all the data which is taken to a cloud, it is the order of the day. Okay, so we are have a good HMI data acquisition and other thing. We are connecting to directly to the network, and we are able to monitor somewhere sitting on a place. Okay, that's the order of the day. We may not be able to avoid that. But in this aspect, the main problems which is happen or it is paved way a lot of challenges for our research community because of different attacks and other things which is happening. Okay, how to differentiate, how to able to do that. So, and the people why they are going for this type of a system, more responsive, precise, reliable, efficient, and remote access monitoring. Even you can able to see it. Even for example, the example we are planning to take. Is like a large industrial conveyor system which is happening in a Neyveli Lignite Corporation. So during a rainy days, okay, the people may not be able to go and assess on what is happening in their mines. Okay, that's what this actually this project came to our IIT Trichy. Why not we can have a complete electronification, what all the challenges and other things which is happened. Okay, that's what we have started and completed that project. And based on that, now we are working on that, how that cyber issues will comes into the picture. Okay, maybe like Adan, and it is a real application for smart grids, lot of problems which is happening nowadays. And industrial physical system, automated vehicle. Yesterday also we have a robots, healthcare, etc. In everywhere, this is the main issue. Okay, these challenges we make, okay, various cyber attacks which is introduced by intruders and at a different dimensions, we may not be able to differentiate. That's one of the challenges. Okay, it's maybe in a software or a firmware. That is another issue. Okay, and also what will happen, many type of confusions may be created because of the false noise, disturbance, and we have to differentiate between these issues along with this. Okay, and also the network constraint, that is also be a part and parcel like a network delay, packet loss, network constraints. Okay, these all the things we have to think about whenever if you want to go for a industrial perspective. Okay, we are not addressing all the things, just we are giving an overview. And next. So this is that as I told earlier, this is the conveyor system which we have procured under this project. This is okay, so we have here, like that coal and other thing, it has to fell down. This is a typical conveyor system which has a 4 induction motor which has a 2.2 kilowatt rating, and we have a vibration sensor to measure the healthiness of a motor and gearbox. That is also be a first measurement, and we have a voltage, current, CTPT, and all the information we are taking into a cloud. That's a thing. And we are measuring a surface temperature and winding temperature by using a RTD, resistant temperature detector, and energy meter, as I told already, CT and PT. Okay, this is a large setup which we had laboratory level, and this. Okay, this is that how the data is acquired on this particular one, and how it is transferred to a cloud. And these are all the different, we have used a Centron PAC by means of a Siemens, and we have a voltage, okay, different motors, total apparent power, active power, reactive power, energy, and a current. All the parameters we are getting and we are sending to a cloud. Okay, that's a monitoring. And what are the different attacks which has been created, how it is done, because it is purely my research scholar did. So she also attending. If she present, that will have a more meaningful. And any clarification, I can also join.
Very good morning to one and all. Actually, my guide had given an overview about it. I'm Tulasi. And actually now, overall heat or whatever problems are coming to a physical system, whichever system in an industry, actually such problems will happen. Fault, noise, disturbance, and main focus is on cyber attacks. But while hearing about the cyber attacks, the first thing which will come to our mind is virus, malware. But more than that, many type of attacks are present in the industries actually. So this false data injection attack is one of the attack, which is common in most of the industries, where a man or attacker is actually injecting some signals so that the system will get malfunctioned. So here it is like there is a Y signal, which is the actual signal which is transferring from one system to the cloud, or from the cloud back to the system where the control signal if we are considering. And then attack is the signal which is injected to the signal by an attacker or intruder. So here there will be some range of values which can be related to the system values if the attacker knows about the system. And if he don't know, actually that can be a random values also. Okay, so this Dell attack, actually there can be many type of signals. First of all, that can be a periodic function, and it can be a periodic pulse actually given in a very basic intervals, and a constant value also. And another thing, it can be a continuous attack which is given and all over the time the attack persists. And another type is like instantaneous attack. At a particular time instance, the attacker is injecting the signal. So that is also another one thing. And we are going for the instantaneous attacks solely. And that too taken in random instant, we are injecting the attack to the signal. So we are considering constant magnitude also at particular instant, and considered with a different magnitude. So attack is one thing, and we told three more things: fault, noise, and disturbance. So fault is not considered in the work, and noise and disturbance only we considered. And one is state noise, measurement noise. I hope you all know as the chemical engineers. And for the noise, actually the magnitude will be very less, as well as the frequency will be high. And for the disturbance, there will be internal disturbance and external disturbance. For example, actually there will be voltage fluctuation to a system, or otherwise load variations can happen. And based on that, the output of the system or the performance of the system will get varied. So while coming to the basic block diagram, there is a conveyor belt systems are already explained about it, and many sensors and actuators are there. And primarily there are actually 4 motors which is driving the conveyor belt. Okay, so for the 4 motors, there are different energy meters, that is Siemens, Centron, PAC meters. So from there actually we are getting the output of voltage, current, frequency, etc. So it's already mentioned in the previous slide. We are taking the phase voltage only here. So these values are just transferring to the cloud, just for a remote monitoring purpose. So there is a person who is sitting in the away or some other place, maybe another country, maybe another location. So he is monitoring for seeing how the system is working or performing. So while the communicating or transferring the data from the system or actually from the cloud to the person who is monitoring it, there is a chance of attacking because the attackers are always looking into the communication channel. So at that time, we are considering only FDIS. So the attacker can inject a data along with the signal which we are transmitting. Okay. So after acquiring the signal, once we need to know what we got is actual data or not, or whether it is attacked or not. So for that classification here, one LSTM based technique is used. And there we are just checking whether it is attacked, but there is a chance that noise also happens. So we need to know whether the data is noisy or disturbance happened. That's why the performance is getting varied or not. So it's a long short-term memory autoencoder model. Actually, it is a basic thing, and I will just plot the idea. Okay, so first thing is that we are giving the input, then actually there are two parts, encoder as well as decoder. So it's a type of reconstruction, and we are giving all the data. Here the data we considered is from the energy meters only. We are not considering all the sensor or actuator data, only from the energy meters. So already I gave actually 9 inputs. 3 phase voltages, then 3 type of power, active, reactive, and apparent power, as well as the energy and frequency. These values are considered and it is given by the energy meter itself. So this is given to the LSTM system. So for the LSTM system, actually there are 9 inputs, these 9 values which I told right now. And then 100 LSTM neurons as a layer, and finally 1 output. Then actually the mirror image of the part as a decoder. Okay, so while coming to the results and discussion, this is the data acquisition part. Using a Modbus, we are acquiring the data of the energy meter to the system, and then actually we need to push it into the cloud. So here actually using, I gave the IP address and all the inputs actually. So here actually the data is pushed to the ThinkSpeak server. So here actually, while before pushing for the experiment purpose, we are injecting the abnormality or the attack as some constant values only. This is only considered for this purpose, but we can go for other types of attack also in future. So these are all the values are pushed to the cloud, and it is the visualization. Then actually this I just represent it as an image actually from the energy meters. All the inputs are given to the LSTM based autoencoder. Then encoder is the actually after the decoding, the data are getting reconstructed. At that time, actually the values what we are getting will be somewhat related to the actual thing. So there is a comparison between whatever the real data is and the reconstructed data is. So while during the comparison, we will get some errors. Okay, what actual data is and reconstructed data is, based on that error will occur, and the error will say actually which type of abnormality is happened there. So these are the result actually. The first comparison is giving, this is a single attack thing. So at that time, we will get a very big high negative peak. Negative or positive doesn't matter. We need the variations only here. So we are getting a peak. So how we are considering it as an attack? Actually, we are giving a threshold value. So we are just considering or assuming it as if the value is beyond that threshold, that variation is beyond the threshold, we are considering it as an attack. Because no attacker want to insert a very minute value which won't affect the system performance too much. So here actually we can detect an attack, and the same way the next case actually we are giving a multiple attack, actually considering two value as a variation. So it is an assumption actually. So here multiple attacks we are detecting using the system. So again coming noise, it's actually somewhat ignorable only because the amplitude is very less, And after that, the disturbance signal, the difference will be somewhat like that. And the person who is monitoring from the other end can identify what is happening to the system, whether it is attack, noise, or disturbance is affecting the system, and why the system performance is getting varied. So as a conclusion, actually, I'm telling that the monitoring and control from the remote area is vital nowadays, especially. And the things are getting everything through the cloud, and we are sending the data. We can control here. Controlling is not done. Actually, we are talking about the monitoring purpose only. So, but control can also done from the remote areas. So at that time, whatever data we are sending to the cloud, and whatever the other person is taking the decisions based on the data. So the security as well as the privacy of the data is very important, which we cannot ignore. So here an LSTM based attack detection algorithm is developed and only consider the FTA attack at the presence of noise as well as the disturbance. And this technique actually works well for the real-time system. Whenever it works, actually a physical system is working at the same time, it's with a few seconds of delay due to the communication, we can detect whether which type of abnormality is facing by the system. And as a future work, actually planning to consider a type of fault, and after that, different types of attack also along with this. Thank you.
Any questions? How did you perform that cyber attack so that you're introducing an attack and multiple attacks? How did you perform those attacks?
Okay, you are asking how I am injecting the attack signal. Actually, we cannot hack it and inject actually. So as a performance, for the experiment purpose, actually, I varied the signal itself. I will push it to the cloud. There is a mathematical model based on different type of attacks, different model is there. Based on that, actually, I did.
So have you looked at, you measure everything, right? You measure voltage, current, power, active power, reactive power. Now you can compute the power and see that it really tallies, right? So that kind of, so whether your data is really hacked or not. Maybe I'm not able to pinpoint which voltage got affected or which current got affected, but largely I can say, there is an attack.
Sir, yes, sir. Actually, what you are telling is a point, but here we are making a generic system, not only for energy meters from which we can derive the power. Actually, it can be for a sensor system or even actuator signal. In that case, we need a generic method. For each system, we cannot implement different algorithm. Okay, it is possible, but we are looking for a generic thing. So for a sensor, we cannot do such a derivative things, no, sir. That's why.
How you will distinguish between the fault detection and diagnosis and cyber attack, because they are looking, both are similar, because I saw in poster session same kind of autoencoder used for the fault detection. So how these two things are different?
Yes, actually, that is one thing.
Both are similar.
I told that I will get in, I will consider it also, but some mathematical models seem similar. I'm also agreeing, we'll look into it.
I want to know that whether it's the same fault detection and diagnosis in cyber, what you explained, or it's two different things.
Actually, aspect wise, two different things, but the result can be how. Actually, fault can be a sub.
So both the fault and attack, okay, one way in this perspective, you can able to say that both are looks like the same. Okay, in a general sense, both should be identified. Both the fault should also be identified, cyber attack also be identified. But what will happen in this fault, it's a nature of the system. Okay, it's like, something is happening, something is, the controller should not be compensated. Okay, whereas a cyber attack, it's like, completely they will corrupt your data and give you a complete wrong information to the other end. Okay, so by that, this is only a challenging area. Okay, what you told. But the similar method can be adapted for both the sides. Okay, but only thing is we should have to differentiate. Okay, how that nature and characteristics and other. Thank you. It's a good question.
So at the end, you were saying like we are using the LSTM based autoencoder. At the end, we are using the reconstruction. Then we are differentiating this attack, noise, disturbance. So are you putting a threshold there on which basis you are differentiating? Because you are generating a overall system You're saying this is the attack, this is the noise, this is the disturbance. So on which basis you are doing this?
So basically, it's like, she is not explained what she did internally. So basically, it's not only a time domain information, frequency domain information also coming into the picture. From that, we can able to differentiate. First, it's like, your question is how the doctor is differentiate between virus and bacteria.
No, sir,
But just I'm telling, it's a good question. Okay, based on the symptoms, okay, they have to do a further process.
Okay.
So like, noise is like a,
Next session start at 11:40.
yeah.
So we need
Can-
some
can-
time
can
for
you postpone
transition.
it? Yeah,
Yeah, can
exactly.
we hold it?
Yeah, definitely.
Okay.
Okay, thank you.
It's good to see so lively discussion, but for the sake of time.
Definitely we can discuss.
Yeah, I have more questions then.
And based on your question, there are so many inputs.
We'll end the
We
section
started on
now,
this
we
area.
get the transition to the next section.
Okay, thank you, Monica.